And here in this video, we're going to go into Python and Torch, and we're going to import tensor data set and data loader, and we're going to turn a CSV into actual usable data using machine learning and using Python. And I hope that you get a lot out of this video. I hope that you subscribe. If you like somebody who's going to talk to you straight about Python and machine learning and show you a hands-on example of something you can do, I really hope that you subscribe, and let's get right into it. So let's look at the data. So I got this data on, we're just going to call it cases. Okay, that's just going to be the fun word, cases. You can guess what those are cases of, but this is some publicly available data, and we have an index number here, we have a date, we have a state, we have the cases per 100,000, we have a state, county, state code, and zip code. Okay, and what we're going to do is we're going to turn this into useful data, which is going to be assessing each state by risk, by risk. Yeah. So let's go right into it. So the first thing we're going to do is we're going to import pandas as PD. Pandas is a great data manipulation library. You can do it just makes life a whole lot easier. You don't want to be working with the built-in lists and crap like that. Import torch, because it's just going to multiply your code by a whole ton. If you don't use pandas, this is going to be more complicated. And then from torch.utils.data, import tensor dataset data loader. The first one, data loader. And first thing we're going to do, and I've commented all this code out pretty well, load the data from the CSV file. So pandas obviously handles data loading pretty well. Whoops, excuse me. Get the heck out of there. And then the name is cases.csv. We're going to extract the cases per 1,000, 100,000 column as the target variable. And to do that, we're going to do lowercase y equals data, open bracket, cases per 100,000, and then dot values. So we're going to take the values out of there. And then we're going to extract the state column as the input feature. X, uppercase X equals data, state, same thing, dot values. So we're going to get the X and the Y, the data, the state, and the cases per. And then we're going to get, we're going to convert the input and target variables to a PyTorch, or two PyTorch tensors. Uppercase X equals lowercase torch dot from underscore numpy X dot values, and then dot float. Is that right? X dot values dot float, torch dot from, yeah, looks right. Y equals torch dot from numpy lowercase y dot float. There's our X and our Y. Now we're going to do something called creating the data set and data loader. And data set equals tensor data set. And then we pass into it the X and the Y. And create the data loader. Data loader equals data loader. Pass into it the data set. and we set our batch size to equal 32, and shuffle equals true. There's our data loader. Now we're going to define a model, and we'll create a class called net, pass into it torch.nn.module, and from there we're going to define init self super net self init and self.fc equals torch.nn.linear x.shape of 1 and also 1. And that looks right. And then we shall define another one called forward. Pass into a self and x. X equals self.fc of x. We're going to return x. And now we're going to define the loss function and optimizer. Criterion torch.nn.msc loss. I'm going to train the model. Model equals net, and then optimizer equals torch.optim.atom, pass into it model.parameter, parameters, and it looks right. Add a little space there. Clean her up a bit. Model.parameters. Yep, that looks right. Now we're going to do a for loop for epoch in range of 100. For I inputs labels in enumerate data loader. Optimizer dot zero grad. Outputs equals model of the inputs. Loss equals criterion of outputs dot squeeze. This is for some trimming of data values. And labels. Loss dot backward. Optimizer dot step. Okay. Now we have to work with the results. So state underscore state cases equals model of x dot detach dot numpy. State cases equals model of x dot and we're going to create a new data frame to hold the results, whereas these results equals pd.data frame state data of state. And then cases per 100,000. State cases dot Latin. Yeah, that looks right. And we're going to group the states by their cases per and calculate the mean, whereas the mean equals results dot group by state dot mean. Probably gonna be a long video for you guys. I'm at 11 minutes of freaking just blasting through this code. Where was I? And then we're gonna define high underscore risk underscore states equals mean of mean cases per 100,000 greater than the mean of per 100,000 dot mean. I hope that works. I hope there's no. I mean, this is a huge risk when you type out this much code in one in one shot, and then you know it has to run. If it doesn't run, I gotta freaking redo the video. Print high risk cases. Print high risk. Do it the other way. Yeah, that looks right. That looks right. Dot mean. Yeah. Okay. Okay. Now hold on to your butts. So, I mean, this is oh crap. Where are we at here? Number 16. What the heck did I do wrong there? X equals torch. Maybe this will do it. Rerun it and let her run. And while we're waiting for this to load, you can see that this is running and there's a lot going on. It's doing the whole machine learning is quite resource intensive. So while it's running, hit the subscribe button, hit the like button. This is a full tutorial on just some basics of using Python and Pytorch. There might be other ways to do this. There might be more accurate ways that, you know, this might be flawed in some ways, but we're using it and we're going to get an output here. Dead air. Totally dead air. And you also have to remember too that it's like, what does risk mean? What is risk? What is high risk? What does low risk mean? That's there's a bit of interpretation going on there. So what you define risk to be might be different from what somebody else defines it to be.
Your dot your dad was a
All right, there it is. Finally finished. So this is printed out states with high risk and states with low risk. That's how you do it. I mean, that might not be exactly perfect, you know. You might have to tweak it. You might have to look in there a little bit, but it sure is a calculation, and it uses PyTorch. So thanks for watching, and have a great day.